October 19th, 2025. A tropical wave is surging across the Atlantic, racing dangerously close to the equator, just 10 degrees north, right where late-season storms often get their fuel. The National Weather Service has just issued an alert. This system could linger in the Caribbean past Halloween, drifting unpredictably and threatening the U.S. in ways models can barely capture. Right now, forecasters give it a 30% chance of turning into something serious within the next 7 days. But if it stalls, the odds and the risks rise fast. What makes this wave so different, and why are experts suddenly on edge about a storm with no clear path but massive potential consequences? Warm water stretches across the southern Caribbean, running almost uninterrupted from the coast of South America to the Yucatan Channel. Sea surface temperatures here hover between 28 and 29 degrees Celsius, well above the threshold needed for tropical development. The current system, Invest 98L, is tracking along a line just 10 to 12 degrees north of the equator. That southern position gives it a distinct advantage. While storms farther north are already brushing against cooler waters and hostile upper-level winds, this wave is gliding over a deep pool of oceanic heat. Oceanographers measure not just the surface temperature, but the depth of warm water below. In this part of the Caribbean, the upper ocean heat content remains high even into late October. That means if a storm slows down, it can keep drawing energy, not just from the top layer, but from meters below. The result is a kind of thermal reserve, a hidden fuel tank that can support rapid intensification if other conditions line up. Late in the hurricane season, most Atlantic storms lose steam as they move north, running into dry air and cooler currents. But this year, the southern track keeps Invest 98L away from those hazards. Satellite maps show a clear divide. Above 15 degrees north, sea temperatures drop off sharply and wind shear increases. Below that line, the environment is still primed for growth. This isn't just theory. Historical records show that some of the most dangerous late-season hurricanes, like Mitch in 1998 and Eta in 2020, formed or stalled in these same warm waters. Both storms tapped into the deep ocean heat, lingering for days and building strength before making landfall. Meteorologists watch this region closely every October and November, knowing that proximity to land and high oceanic energy can turn a weak wave into a major threat in a matter of days. Right now, the system's forward speed is working against it. Moving quickly, it struggles to organize a closed circulation. But as it slows in the central Caribbean, the potential for development rises. The warm water acts like a safety net, keeping the system alive even if dry air or wind shear tries to disrupt it. The southern latitude also means the storm avoids the early winter fronts that sweep across the northern Atlantic, stripping weaker systems of their core heat. Meteorologists use satellite-derived sea surface temperature charts and upper ocean heat maps to estimate how much energy is available. In these southern waters, the numbers stay stubbornly high, even as the calendar pushes into November. That's why experts warn that any stalling or slowdown in this part of the Caribbean could give the storm a second wind. With so much fuel beneath it, the wave doesn't need to move north to become dangerous. It just needs time and the right break in the atmosphere to tap into the energy below. Wind shear controls the fate of every tropical system in the Atlantic. For Invest 98L, the numbers hover in a gray zone. Moderate, not hostile, but not perfect either. Westerly winds above the surface run about 15 to 20 knots, strong enough to tilt the storm's growing thunderstorms and scatter their heat sideways. That tilt keeps the system from stacking up vertically, which is what a true tropical cyclone needs. The faster the wave moves, the harder it is for a closed circulation to form. Right now, Invest 98L is racing west at 20 to 25 miles per hour. Meteorologists watch for any sign of a slowdown, because only then can the thunderstorms cluster and spin into a core. Forecast models try to capture this delicate balance. Human forecasters and computer algorithms both struggle with the same question. When will the wind shear relax, and will the system slow down enough to take advantage? The National Hurricane Center leans on ensemble models, big collections of slightly different forecasts run in parallel. The European model, the GFS, and AI tools like GraphCast each produce dozens of possible futures. Some runs show the system never closing off at all, just fizzling as an open wave. Others hint at a tropical storm, maybe even a weak hurricane, if the shear drops and the forward speed drops with it. Every day, the odds shift. On October 19th, the NHC bumped the 7-day development chance to 30%. That's up from 10% just 2 days earlier, but it's still a coin flip. When you look across all the major models, the probability that Invest 98L becomes a named storm at all sits near 50%. That means half the time, the system never gets organized enough to earn a name. The other half, it's a matter of how strong and where it might go. The ensemble approach lays out the range. About 20 to 30% of scenarios show the system stalling in the Western Caribbean, caught between weak steering currents and moderate shear. Another 20 to 30% push it north, toward the Greater Antilles, if a dip in the jet stream manages to grab the circulation. The rest keep it moving west, toward Central America, or even let it slip into the Eastern Pacific. No single outcome dominates. This spread is why meteorologists call the late October forecast super unreliable. Shear and speed act like gatekeepers. If the winds aloft drop by even 5 knots, or if the system slows below 15 miles per hour, the odds of development jump. But as long as the current pattern holds, the wave remains in limbo, too fast and too tilted to spin up, but stubbornly persistent thanks to the deep ocean heat. The result is a forecast that stays probabilistic, not deterministic. There's no sharp line between a harmless wave and a named storm, just a set of odds that update with every satellite pass and every new model run. For now, the numbers frame the story. 1 in 2 chance of development, 1 in 4 for any given scenario, all of it hinging on whether wind shear relaxes and the system finally slows down. Until then, the Caribbean stays in a holding pattern, waiting for the next atmospheric break. By late October, the Western Caribbean becomes a trap for tropical systems. Steering currents collapse, leaving storms stranded between faint pushes of air that never quite decide on a direction. For Invest 98L, this is the scenario that draws the most concern from forecasters. The models show a tangle of tracks looping and stalling over the same patch of warm water. Some ensemble runs keep the system drifting for days, even a week, with no clear escape route. When the steering winds weaken, the wave can meander aimlessly, changing course with every subtle shift in the atmosphere. Predicting where it will go next becomes nearly impossible. Meteorologists call this the stall zone. And in their words, once a system gets stuck here, forecasts turn super unreliable. This isn't just a technical problem. The longer a system lingers over the hot Caribbean, the more energy it can draw from the ocean below. That's how Hurricane Mitch in 1998 became one of the deadliest storms in history. Mitch stalled for days, dumping rain, building strength, and leaving forecasters scrambling to keep up as the models broke down. The same pattern played out with Eta in 2020, when the storm's erratic path left Central America and later the Gulf Coast with little time to react. For Invest 98L, the stall scenario takes shape as early as October 26th or 27th. By then, the forward motion slows to a crawl. The system may finally organize a closed circulation, but with nowhere to go, it just spins and drifts. Some model runs show a lazy loop, others a zigzag path between Jamaica, the Yucatan, and Cuba. The spread in possible tracks widens by the day. Forecasters warn that in this pattern, kind of all bets are off. There's no way to pin down a landfall, no way to say which coast should prepare. The only certainty is uncertainty itself. Each new model run brings a fresh set of possibilities. The European ensemble, the GFS, and the latest AI tools all agree on one thing. Once the system stalls, confidence in the forecast collapses. Emergency planners and families along the Gulf Coast, Florida, and the Western Caribbean are left watching, waiting, and hoping for a clear signal that never quite comes. The anxiety grows as the days pass. History shows that a stalled storm in this region can turn quiet seas into chaos with almost no warning. A sharp dip in the jet stream is forecast to sweep across the western Atlantic around October 23rd. That single kink in the upper-level winds could change everything for Invest 98L. If the system organizes quickly, stacking thunderstorms into a tight core, mid-latitude winds may catch hold and pull it north. The first islands in the crosshairs are Jamaica, Hispaniola, Puerto Rico, and the eastern tip of Cuba. The Bahamas, Turks and Caicos, and even the Virgin Islands sit on the edge of the projected cone, depending on how fast the system spins up. Meteorologists track this scenario with a mix of caution and urgency. The timing is tight. If the storm remains weak, the jet stream passes overhead without notice, leaving the system to drift. But if it strengthens by Wednesday, the odds of a northern turn shoot up. Model guidance splits dramatically here. Some ensemble runs swing the system toward the Dominican Republic and Haiti, bringing heavy rain and wind to densely populated coastlines. Others bend the path toward Jamaica or eastern Cuba, where mountainous terrain could wring out torrential downpours and trigger flash floods. The island track has played out before. Hurricane Sandy in 2012 took a similar path, drawn north by a late October trough. The difference this time is the uncertainty in timing. Just a day or two in storm development could mean the difference between a glancing blow and a direct hit. Local weather services across the Greater Antilles issue early advisories, urging residents to check supplies and review emergency plans. Forecast models show a 20 to 30% chance of this northern scenario. The European model, GFS, and new AI tools each produce their own spaghetti plots, lines looping north, some making landfall, others curving out to sea. No single solution dominates, but the risk to the islands is real. The next 72 hours become a waiting game. Every new satellite image, every shift in model output brings a fresh wave of anxiety for families from San Juan to Kingston. For now, the jet stream holds the keys. If it dips far enough south, and if Invest 98L is ready, the islands could face a late-season tropical threat before the month is out. Westward tracks always linger in the background of late-season forecasts. For Invest 98L, several ensemble runs push the system straight across the Caribbean, past the Yucatan, and into Central America. In these scenarios, the wave never organizes enough to get caught by the jet stream. Instead, it keeps moving west, sometimes weakening over land, sometimes slipping into the Pacific. Meteorologists have seen this before. In 2020, Hurricane Eta crossed Nicaragua, lost its punch, then reformed in the eastern Pacific as a new storm. The models do not rule out a repeat. About a quarter of current runs show this outcome, a quiet fade over Central America, or a crossover and rebirth on the other side. But there is a wild card that keeps popping up in the model tales. If Invest 98L manages to organize in the Western Caribbean, and if the steering currents shift just enough, there is a window for the system to turn north and enter the Gulf of Mexico. This is where the stakes rise for the United States. During a Fox 26 Houston tropical update on October 19th, the station's meteorologist put it this way: "There is a whole lot of questions to still be dealing with. For you folks in the Caribbean who are watching, this is what we need to be concerned with and watch several days down the line." The message is clear. No one can dismiss the Gulf scenario outright, even if the odds are low. Model guidance splits sharply beyond 5 days. Some runs keep the system pinned against Central America, while a handful swing it north, threading the gap between the Yucatan and Cuba. The uncertainty is so high that forecasters avoid pinning down any one solution. The National Hurricane Center gives roughly a 20 to 30% chance for the westward or crossover path, but warns that small changes in strength or steering could flip the script. If the system stays weak, it drifts west. If it organizes, the Gulf stays in play. For families and emergency managers along the Gulf Coast, that uncertainty is hard to ignore. Every late October, memories of storms like Mitch and Eta resurface, systems that looked harmless one day, then turned deadly the next. The possibility of a Gulf impact, even if questionable, keeps planners alert. Meteorologists stress that, for now, the westward track is just one piece of a tangled puzzle. But as long as the system survives in the Caribbean, the risk to the U.S. remains on the table. Forecast desks fill with spaghetti plots, dozens of colored lines, each one tracing a possible path for Invest 98L. The European model, known as ECMWF, lays out the widest fan. Its ensemble runs scatter tracks in every direction. Some curl north toward the Greater Antilles, others loop in lazy circles over the Western Caribbean, and a handful drift west toward Central America. The GFS, the main American model, clusters its solutions tighter at first, but by day 5, its lines split sharply. Half veer north, half wander west, and a few stall in place, caught in the same atmospheric dead zone that has tripped up so many storms before. Analysts pore over these maps, searching for consensus. On October 19th, the ECMWF ensemble shows a clear bias towards stalling. The majority of its members keep the system trapped between Jamaica and the Yucatan. The GFS, on the other hand, leans slightly more toward a northern escape, with several runs pulling the system up toward Cuba and the Bahamas, if the jet stream dips at just the right moment. But even within the same model suite, the spread is dramatic. One member might show a sharp turn north, another a slow crawl west, and a third a tight loop that never leaves the Caribbean Sea. Spaghetti plots reveal the core challenge. Every line represents a plausible future, but none can be trusted alone. The ECMWF has a reputation for capturing uncertainty, often highlighting scenarios that other models suppress. Its spread this week is especially broad, reflecting the unpredictable nature of weak steering currents and marginal wind shear. The GFS, meanwhile, sometimes jumps early at development, spinning up a tropical storm before the system is ready. Both models rely on slightly different physics and data inputs, which means their disagreements are not just random noise. They reflect real-world ambiguity in the state of the atmosphere. Meteorologists compare the ensemble means, looking for overlap. In this case, the overlap is a mess. No clear corridor, no dominant path. The most consistent feature is the stall zone in the Western Caribbean. Both ECMWF and GFS suggest that if Invest 98L slows down by October 26th, it could become trapped for days. From there, the possibilities multiply. A northward run if the jet stream dips, a westward drift if the steering currents collapse, or a looping pattern if neither force wins out. The odds for each scenario hover between 20 and 30%, with no single solution standing out. Spaghetti plots aren't just a curiosity. They shape how emergency managers and the public respond. A tight cluster means confidence. A wide fan means confusion. This week, The plots are as wide as they get. The message from the models is clear. Nothing is locked in. Every outcome, from a harmless open wave to a late-season hurricane, remains on the table. For now, the only certainty is the uncertainty itself. AI models are now in the mix, changing how forecasters see Invest 98L's future. Google DeepMind's GraphCast is the newest tool on the desk, running thousands of simulations in minutes. Its results show a wider spread than even the European ensemble, with some tracks curling sharply north, others drifting into the Gulf, and a few stalling for days over the Western Caribbean. On October 19th, GraphCast's spaghetti plots fan out across the map, pushing the boundaries of what's considered possible. A handful of runs show the system threading the Yucatan Channel and strengthening over the Gulf, scenarios that traditional models mostly keep in the margins. This is where the debate starts. Human analysts and model developers meet on Slack threads and video calls, arguing over how much weight to give these AI outliers. Some warn that GraphCast's wildest tracks could be statistical noise, not real threats. Others point to past storms, like Eta in 2020, that followed paths no one expected, arguing that even a 5% scenario can't be ignored when millions live along the coast. Intensity is another sticking point. The HWRF model, built for hurricane physics, is notorious for running hot after genesis. Once a closed circulation forms, HWRF often jumps straight to tropical storm or low-end hurricane, sometimes before the system is ready. Analysts know this bias and adjust their expectations, but when HWRF and GraphCast both show a sharp ramp-up in the same window, nerves rise. Post-Genesis, HWRF's intensity forecasts are treated with more respect. Its track record improves once a storm actually spins up. GraphCast, on the other hand, tends to lag on rapid intensification. It's conservative about blowing up a weak system into a hurricane, but it excels at showing the full range of possible outcomes. This week, its ensemble includes rare but dramatic outlier runs, tracks that swing north into the Gulf or loop in the Western Caribbean before shooting toward Florida. The odds for any one of these are low, but the fact they appear at all keeps forecasters on edge. The core question is how to treat these outliers. Some meteorologists argue for focusing on the consensus, the thickest part of the spaghetti plot. Others say the tails matter most, because history shows that the most damaging storms are often the ones that break the mold. The National Hurricane Center ultimately takes a blended approach, highlighting the most likely paths but flagging the outliers in briefings to emergency managers. In their words, if this system stalls in the Western Caribbean, kind of all bets are off. For the public, this means uncertainty lingers. Emergency planners in Texas, Florida, and the Gulf Coast hear about low probability but high impact scenarios and face a dilemma. Act too soon and risk false alarms, wait too long and risk being caught off guard. The AI era brings more data, more possibilities, and more anxiety. Every new model run is a fresh roll of the dice, and no one, not even the smartest algorithm, can say for sure which track will win out. In Galveston, a family-owned restaurant sits just 2 blocks from the seawall. Every fall, the owners watch the forecasts and count the days until hurricane season ends. This year, the wait feels endless. With Invest 98L stalling somewhere out in the Caribbean, the family faces a choice: cancel weekend events and lose revenue, or gamble that the storm never comes. Supplies cost money. Canned food, bottled water, extra fuel for the generator. Each item adds up. Their daughter, a high school senior, asks if her birthday party should be postponed again. Last year, they lost power for 3 days after a tropical storm grazed the coast. The memory lingers, making every new advisory harder to ignore. Across the street, a bait shop closes early. The owner posts a sign, "Back soon, watching the weather." He spends the afternoon on the phone with his insurance agent, asking about flood coverage and business interruption clauses. The last policy renewal came with a warning. Too many claims and rates will jump next year. He checks his inventory, then drives to the hardware store for plywood, just in case. The clerk says he's not the first. By sunset, the lumber aisle is half empty. No one knows if they'll need it, but no one wants to be caught off guard. A block inland, a family of 5 loads their SUV with bottled water, diapers, and canned soup. The father scrolls through spaghetti plots on his phone, looking for reassurance. Each model run seems to tell a different story. His wife asks if they should leave early, before the roads fill up. He hesitates. Every day spent away from work means lost wages, but waiting too long could mean getting stuck in traffic or worse. The uncertainty weighs on them. Their youngest son senses the tension and asks why everyone seems so worried. Business owners debate whether to cancel deliveries. A florist delays a wedding order, afraid the storm will force a last-minute closure. A hotel manager fields calls from guests asking about refunds. Each decision has a cost. Across the Gulf Coast, families and small businesses balance hope and anxiety, watching the forecasts and trying to plan for a future that feels just out of reach. Weekly briefings stretch from Houston to Charleston, each call packed with county officials, state coordinators, and federal advisors. The topic is always the same. How do you plan for a storm that might never come, or might arrive 2 weeks from now with barely a day's notice? On October 21st, emergency managers in Texas debate whether to move generators and cots to staging areas near the coast. In Florida, logistics officers weigh the cost of pre-deploying water and tarps, knowing that every mile closer to the Gulf means more money spent if the system fizzles. No one wants to be caught flat-footed, but no one wants to explain wasted resources to their county commissioners either. The early November timeline complicates every decision. The National Hurricane Center's guidance is clear. The earliest possible U.S. impact comes after the first of the month. That buys time, but it also stretches nerves. Each day, the models shift. One morning, the spaghetti plots show a tight cluster toward the Yucatan. By the afternoon, the lines fan out toward the Florida Panhandle. Regional directors track these swings on their phones, comparing notes in real time. "If we act too soon, we'll look foolish," one Louisiana official tells his team. "But if we wait, we could lose the window to move people safely." The so-called wobble period, when the system could drift in the Caribbean for up to a week, keeps everyone guessing. In North Carolina, school superintendents ask if they should adjust calendars for possible closures. In Alabama, hospital administrators check backup generator contracts, just in case. The uncertainty seeps into every planning session. Past storms like Mitch and Ida are never far from mind. Both stalled, both caught emergency managers off guard, both forced last-minute evacuations that stretched resources thin. Federal agencies urge a careful balance. FEMA's weekly memos remind states to prepare for prolonged uncertainty and to update shelter readiness plans. Local officials push back, pointing to the cost of mobilizing staff and supplies when the odds remain just above a coin flip. Still, the memory of late-season surprises lingers. In Mississippi, the emergency management director sums it up. "We plan for the worst, hope for the best, and try not to get burned by the models." As October closes, the tension between action and patience grows sharper. Every briefing ends with the same refrain: "Stay ready, but don't overreact." The only thing everyone agrees on is that, as long as Invest 98L wobbles in the Caribbean, the stakes for the Gulf and Southeast remain stubbornly high. and the price of guessing wrong rises with every passing day. As of October 19, 2025, the National Hurricane Center assigned a 30% chance that Invest 98L will develop into a tropical system over the next 7 days. Historically, late-season storms in the Caribbean, like Hurricane Mitch in 1998, have shown that warm waters and stalled steering currents can create unpredictable and dangerous situations close to land. This year, ensemble models from the European Center for Medium-Range Weather Forecasts, the Global Forecast System, and Google DeepMind disagree on the storm's path, splitting between a western Caribbean stall, a northern track toward the islands, and a westward push toward Central America, with each scenario holding only a 20 to 30% probability. The storm's southern position increases its chances of persistence but leaves forecasters unable to rule out significant U.S. impacts in early November. For now, uncertainty remains. No model can yet resolve whether this system will threaten the Gulf Coast, the Caribbean islands, or simply fade away. As emergency officials continue weekly briefings, the evidence is clear. Late-season Caribbean storms demand vigilance, and all bets are off until the system's path becomes certain.